Open Stax Psychology Chapter 7, Section 7.1 continued. Schemata. A schema is a mental construct consisting of a cluster or collection of related concepts. There are many different types of schemata, and they all have one thing in common. Schemata are a method of organizing information that allows the brain to work efficiently. When a schema is activated, the brain makes immediate assumptions about the person or objects being observed. There are several types of schemata. A role schema makes assumptions about how individuals in certain roles will behave. For example, imagine you meet someone who introduces himself as a firefighter. When this happens, your brain automatically activates the firefighter schema and begins making assumptions that this person is brave, selfless, and community-oriented. Despite not knowing this person already, you have unknowingly made judgments about him. Schemata also help you fill in gaps in the information you receive from the world around you. While schemata allows for more efficient information processing, there can be problems with schemata regardless of whether they are accurate. Perhaps this particular firefighter is not brave. He just works as a firefighter to pay the bills while studying to become a children's librarian. An event schema, also known as cognitive script, is a set of behaviors that can feel like a routine. Think about what you do when you walk into an elevator. First, the doors open and you wait to let exiting passengers leave the elevator car. Then, you step into the elevator and turn around to face the doors, looking for the correct button to push. You never face the back of the elevator, do you? And when you're riding in a crowded elevator and you can't face the front, it feels uncomfortable, doesn't it? Interestingly, event schemata can vary widely among different cultures and countries. For example, while it is quite common for people to greet one another with a handshake in the US, in Tibet you greet someone by sticking your tongue out at them, and in Belize you bump fists. Because event schemata are automatic, they can be difficult to change. Imagine that you are driving home from work or school. This event schema involves getting in the car, shutting the door, and buckling your seatbelt before putting the key in the ignition. You might perform this script 2 or 3 times each day. As you drive home, you hear your phone ringtone. Typically, the event schema that occurs when you hear your phone ringing involves locating the phone and answering it or responding to your latest text. So without thinking, you reach for your phone, which could be in your pocket, in your bag, or in the passenger seat of the car. This powerful event schema is informed by the pattern of behavior and the pleasurable stimulation that a phone call or text gives your brain. Because it is a schema, it is extremely challenging for us to stop reaching for the phone, even though we know that we endanger our own lives and lives of others while we do it. Remember the elevator? It feels almost impossible to walk in and not face the door. Our powerful event schema dictates our behavior in the elevator, and it is not different with our phones. Current research suggests that it is a habit or even schema of checking our phones in many different situations that makes refraining from checking them while driving especially difficult. Because texting and driving has become a dangerous epidemic in recent years, psychologists are looking at ways to help people interrupt the phone schema while driving. Event schemata like these are the reasons why many habits are difficult to break once they have been acquired. As we continue to examine thinking, keep in mind how powerful the forces of concepts and schemata are to our understanding of the world. Section 7.2 Language. Language is a communication system that involves using words and systematic rules to organize those words to transmit information from one individual to another. While language is a form of communication, not all communication is language. Many species communicate with one another through postures, movements, odors, or vocalizations. This communication is crucial for species that need to interact and develop social relationships with their conspicuous. However, many people have asserted that it is language that makes humans unique among all of the animal species. This section will focus on what distinguishes language as a special form of communication, how the use of language develops, and how language affects the way we think. Components of language. Language, be it spoken, signed, or written, has specific components, a lexicon, and a grammar. Lexicon refers to the word of a given language. This lexicon is a language vocabulary. Grammar refers to a set of rules that are used to convey meaning through the use of lexicon. For instance, English grammar dictates the most verbs receive an ed at the end to indicate past tense. Words are formed by combining the various various phonemes that make up the language. A phoneme, the sounds a versus e, is a basic sound unit of a given language, and different languages have different sets of phonemes. Phonemes are combined to form morphemes, which are the smallest units of language that convey some type of meaning. We use semantics and syntax to construct language. Semantics and syntax are part of a language grammar. Semantics refer to the process by which we derive meaning from morphemes and words. Syntax refer to the way words are organized into sentences. We apply the rules of grammar to organize the lexicon in novel and creative ways, which allow us to communicate information about both concrete and abstract concepts. We can talk about our immediate and observable surroundings as well as the surface of unseen planets. We can share our innermost thoughts, our plans for the future, and debate the value of a college education. We can provide detailed instruction for cooking a meal, fixing a car, or building a fire. The flexibility that language provides to relay vastly different types of information is a property that makes language so distinct as a mode of communication among humans. Language development. Given the remarkable complexity of a language, one might expect that mastering a language would be an especially arduous task. Indeed, for those of us trying to learn a second language as adults, this might seem to be true. However, young children master language very quickly with relative ease. B.F. Skinner proposed that language is learned through reinforcement. Noam Chomsky criticized this behaviorist approach, asserting instead that the mechanism underlying language acquisitions are biologically determined. The use of language developed in the absence of formal instruction and appears to follow a very similar pattern in children from vastly different cultures and backgrounds. It would seem, therefore, that we are born with biological predispositions to acquire a language. Moreover, it appears that there is a critical period for language acquisition such that this proficiency at acquiring language is maximal early in life. Generally, as people age, the ease at which they acquire and master new languages diminishes. Children begin to learn about language from a very early age. In fact, it appears that this is occurring even before we are born. Newborns show preferences for their mother's voice and appear to be able to discriminate between the language spoken by their mother and other languages. Babies are also attuned to the languages being used around them and show preference for videos of faces that are moving in synchrony with the audio of spoken languages versus videos that do not synchronize with the audio. You may recall that each language has its own set of phonemes that are used to generate morphemes, words, and so on. Babies can discriminate among the sounds that make up a language. Early on, they could differentiate between the sound of all human language, even those that do not occur in the languages that are used in their environments. However, by the time they are about 1 year olds, they can only discriminate among these phonemes that are used in the language or languages in their environment. After the first few months of life, babies enter what is known as the babbling stage, during which time they tend to produce single syllables that are repeated over and over. As time passes, more variation appears in their syllables that they produce. During this time, it is unlikely that the babies are trying to communicate. They are just as likely to babble when they are alone as when they are with caregivers. Interestingly, babies who are raised in environments in which sign language is used will also begin to show babbling in the gestures of their hands during this stage. Generally, a child's first word is uttered sometime between the ages of 1 year to 18 months, and for the next few months the child will remain in the one-word stage of language development. During this time, children know a number of words, but they only produce one-word utterances. The children's early vocabulary is limited to familiar objects or events, often nouns. Although children in this stage only make one-word utterances, these words often carry larger meaning. So, for example, a child saying cookie should be identifying a cookie or asking for a cookie. As a child's lexicon grows, she begins to utter simple sentences and to acquire new vocabulary at a very rapid pace. In addition, children begin to demonstrate a clear understanding of the specific rules that apply to their languages. Even the mistakes that children sometimes make provide evidence of just how much they understand about those rules. This is sometimes seen in the form of overgeneralization. In this context, overgeneralization refers to an extension of a language rule to an exception to the rule. For example, in English, it is usually the case that an S is added to the end of a word to indicate plurality. For example, we speak of one dog versus two dogs. Young children will overgeneralize this rule to cases that are exceptions to the add an S to the end of the word rule and say things like those two gooses and three mooses. Clearly, the rule of the language are understood, even if the exceptions to the rules are still being learned. Language and thought. When we speak one language, we agree that words are representations of ideas, people, places, and events. The given language that children learn is connected to their culture and surroundings, but can words themselves shape the way we think about things? Psychologists have long investigated the question of whether language shapes thoughts and actions, or whether our thoughts and beliefs shape our language. Two researchers, Edward Sapir and Benjamin Lee Whorf, began this investigation in the 1940s. They wanted to understand how the language habits of a community encourage members of the community to interpret language in a particular manner. Sapir and Whorf proposed that language determines thought. Language determines thoughts, suggesting, for example, that a person whose community language did not have past tense verbs would be challenged to think about the past. Researchers have since identified this view as too absolute, pointing out a lack of empiricism behind the Sapir and Whorf proposed. Today, psychologists continue to study and debate the relationship between language and thought. Language may indeed influence the way we think, an idea known as linguistic determinism. One recent demonstration of this phenomenon involved the differences in the way that English and Mandarin Chinese speakers talk and think about time. English speakers tend to talk about time using terms that describe changes along a horizontal dimension. For example, saying something like, "I'm running behind schedule," or "don't get ahead of yourself." While Mandarin Chinese speakers also describe time in a horizontal term, it is not uncommon to also use terms associated with vertical arrangements. For example, the past might be described as being up and the future as being down. It turns out that these differences in language translate into differences in performance on cognitive tests designated to measure how quickly an individual can recognize temporal relationships, specifically when given a series of tasks with vertical priming. Mandarin Chinese speakers were faster at recognizing temporal relationship between months. Indeed, Brodisky sees these results, suggesting that habits in language encourage habits in thought. One group of researchers who wanted to investigate how language influences thought compared how English speakers and the Dene people of Papua New Guinea think and speak about color. The Dani have two words for color, one word for light and one word for dark. In contrast, the English language has 11 color words. Researchers hypothesize that the number of color terms could limit the ways that the Dani people conceptualize color. However, the Dani were able to distinguish colors with the same ability as English speakers, despite having fewer words at their disposal. A recent review of research aimed to determining how language might affect something like color perception suggests that language can influence perception phenomena, especially in the left hemisphere of the brain, You may recall from earlier chapters that the left hemisphere is associated with language for most people. However, the right of the brain is less affected by linguistic influences on perception. Section 7.3 Problem Solving. People face problems every day, usually multiple problems throughout the day. Sometimes these problems are straightforward. To double a recipe for pizza dough, for example, all that is required is that each ingredient of the recipe be doubled. Sometimes, however, the problems we encounter are more complex. For example, say at work you have a deadline, and you must mail a printed copy of a report to your supervisor by the end of the business day. The report is time sensitive and must be sent overnight. You finished the report last night, but your printer will not work today. What should you do? First, you need to identify the problem and then apply a strategy for solving the problem. Problem-solving strategies. When you are presented with a problem, whether it is a complex mathematical problem or a broken printer, how do you solve it? However, finding a solution to the problem must first be clearly identified. After that, one of many problem-solving strategies can be applied, hopefully resulting into a solution. A problem-solving strategy is a plan of action used to find a solution. Different strategies have different action plans associated with them. For example, a well-known strategy is trial and error. The old adage, if at first you don't succeed, try again. Describe trial and error. In terms of your broken printer, you could try checking the ink levels, and if it doesn't work, you could check to make sure the paper tray isn't jammed. Or maybe the printer isn't actually connected to your laptop. When using trial and error, you would continue to try different solutions until you solve the problem. Although trial and error is not typically one of the most time-efficient strategies, it is a commonly used one. Another type of strategy is an algorithm. An algorithm is a problem-solving formula that provides you with step-by-step instruction used to achieve a desired outcome. You can think of an algorithm as a recipe with highly detailed instructions that produce the same result every time they are performed. Algorithms are used frequently in our everyday lives, especially in computer science. When you run a search on the internet, search engines like Google use algorithms to decide which entries will appear first on your list of results. Facebook also uses algorithms to decide which posts to display on your newsfeed. Can you identify other situations in which algorithms are used? A heuristic is another type of problem-solving strategy. While an algorithm must be followed exactly to produce correct results, a heuristic is a general problem-solving framework. You can think of these as mental shortcuts that are used to solve problems. A rule of thumb is an example of a heuristic. Such a rule saves a person time and energy when making a decision, when despite its time-saving characteristics, it is not always the best method of making a rational decision. Different types of heuristics are used in different types of situations, but the impulse to use a heuristic occurs when one of 5 conditions is met. One is faced with too much information, when the time to make a decision is limited, when the decision to be made is unimportant, when there is access to very little information to use in making the decision, when an appropriate heuristic happens to come to mind in the same moment. Working backwards is a useful heuristic in which you begin solving the problem by focusing on the end result. Consider this example. You live in Washington, D.C., and you have been invited to a wedding at 4 p.m. on Saturday in Philadelphia. Knowing that Interstate 95 tends to back up any day of the week, you need to plan your route and time your departure accordingly. If you want to be at the wedding service by 3:30 p.m. and it takes 2.5 hours to get to Philadelphia without traffic, what time should you leave your house? You use the working backwards heuristic to plan the events of your day on a regular basis, probably without even thinking about it. Another useful heuristic is the practice of accomplishing a large goal or task by breaking it into series or small steps. Students often use this common method to complete a large research project or long essay for school. For example, students typically brainstorm, develop a thesis or main topic, research the chosen topic, organize their information into an outline, Write a rough draft, revise and edit the rough draft, develop a final draft, organize the reference list, and proofread the work before turning in the project. The large task becomes less overwhelming when it is broken down into a series of small steps. Pitfalls to problem solving. Not all problems are successfully solved. However, what challenges stop us from successfully solving a problem? Albert Einstein once said, "Insanity is doing the same thing over and over again and expecting different results." Imagine a person in a room that has 4 doorways. One doorway that has always been open in the past is now locked. The person, accustomed to exiting the room by that particular door, keeps trying to get out through the same doorway even though the other 3 doors are open. The person is stuck, but she just needs to get to another doorway instead of trying to get out through the locked doorway. A mental set is where you persist in approaching a problem in a way that has worked in the past, but is clearly not working now. Functional fixedness is a type of mental set where you cannot perceive an object being used for something other than what it was designed for. During the Apollo 13 mission to the moon, NASA engineers at Mission Control had to overcome functional fixedness to save the lives of the astronauts aboard the spacecraft. An explosion in a module of the spacecraft damaged multiple systems. The astronauts were in danger of being poisoned by rising levels of carbon dioxide because of problems with the carbon dioxide filters. The engineer found a way for the astronauts to use spare plastic bags, tape, and air hoses to create a makeshift air filter, which researchers have investigated whether functional fixedness is affected by culture. In one experiment, individuals from the Shura group in Ecuador were asked to use an object for a purpose other than that for which the object was originally intended. For example, the participants were told a story about a bear and a rabbit that were separated by a river and asked to select among various objects, including a spoon and a cup, eraser, and so on, to help the animals. It was the only object long enough to span the imaginary river. But if the spoon was presented in a way that reflected its normal usage, it took participants longer to choose the spoon to solve the problem. The researchers wanted to know if exposure to highly specialized tools, as occurs with individuals in industrialized nations, affect their ability to transcend functional fixedness. It was determined that functional fixedness is experienced in both industrialized and non-industrialized cultures. In order to make good decisions, we use our knowledge and our reasoning. Often this knowledge and reasoning is sound and solid. Sometimes, however, we are swayed by biases or by others manipulating a situation. For example, let's say you and 3 friends wanted to rent a house and you had a combined target budget of $1,600. The realtor shows you only very rundown houses for $1,600 and then shows you a very nice house for $2,000. Might you ask each person to pay more to rent to get the $2,000 home? Why would the realtor show you the rundown houses and the nice house? The realtor may be challenging your anchoring bias. An anchoring bias occurs when you focus on one piece of information when making a decision or solving a problem. In this case, you're so focused on the amount of money you are willing to spend that you may not recognize what kind of houses are available at that price point. The confirmation bias is the tendency to focus on information that confirms your existing beliefs. For example, if you think that your professor is not very nice, you notice all of the instances of rude behavior exhibited by the professor, while ignoring cases. Hindsight bias leads you to believe that the event you just experienced was predictable, even though it really wasn't. In other words, you knew all along that things would turn out the way they did. Representative bias describes a faulty way of thinking in which you unintentionally stereotype someone or something. For example, you may assume that your professor spends their free time reading books and engage in intellectual conversations, because the idea of them spending time playing volleyball or visiting an amusement park does not fit in with your stereotype of professors. Finally, the availability heuristic is a heuristic in which you make a decision based on an example, information, or recent experience that readily available to you, even though it may not be the best example to inform your decision. Biases tend to preserve that which is already established, to maintain your pre-existing knowledge, belief, attitudes, and hypotheses. These biases are summarized in Table 7.3.